1901, divers in the Ionian Sea found an ancient shipwreck off the coast of Antikythera Island. The vessel had sunk sometime in the 1st or 2nd century BCE, and it was a treasure trove. Bronze and marble statues littered the sea floor. By 1902, sailors were still exploring the area, and that's when they found the ruins of a computer. The device they found, called the Antikythera mechanism, was an analog computer used to make astronomical calculations, astrological forecasts, and to keep track of the date. This computer was already about 100 years old when the ship wrecked. But according to mainstream history, mechanical devices of this complexity did not exist until the late medieval period. But this computer was built between 100 and 150 BCE. It is undeniable proof that at least a few people were more advanced than previously supposed.
From the first, scientists realized that this was a mechanism for astronomical data. Scrupulously preserved at the National Archaeological Museum of Athens with the other objects from the wreck, the mechanism aroused the curiosity of many researchers. It was only in the 21st century that modern tools for scanning could penetrate the corrosion to reveal in 3 dimensions the interior of the machine. This showed a set of interlocking gears of astounding ingenuity. High-resolution photographs using different exposures brought to light inscriptions on the sides of the machine which appeared to be part of an instruction manual. Scientists compared the numbers inscribed in the text to the number of teeth in the gears and their arrangement, and applied these to the known astronomical cycles of antiquity. Thus, a reliable reconstitution has been made.
All the clues point to the same date, including the metallurgical analysis and especially the text analysis. The form of the letters is typical of the period, and the vocabulary used is found on all the other texts of the same period. Given the extensive information we have, a reliable reconstitution can be made.
Housed in a rectangular frame, the machine shows data on both sides. In front is the larger dial, showing the 365 days of the year according to the Egyptian solar calendar.
Here you can see 4 doubles of gut horns. 1, 2, 3, 4, symbol of 4 direction. East, west, south, north. 4 eyes, okay? 4 seasons. If you collect all, 2, 4, 6, 8, 10, 12 months, okay? Each person has 2 hands. 2 hands per 12. We have 24 hands, 24 hours in the day, and inside horoscope or star signs. The original one now in the Louvre Museum in Paris, but in the ancient time in the ceiling of Temple Dandara near to Luxor in Egypt.
Inside, a second circle shows the 12 signs of the zodiac. By turning a handle, one could position the 2 hands to indicate, for each day of the year, the exact position of the sun and moon, and a small sphere indicating the phase of the moon. In order to guarantee its exactitude, whatever the day or year chosen, a dial on the back of the mechanism shows the metonic cycle, which reflects lunar and solar cycles over a period of 19 years, corresponding to 235 lunar months. of this, another spiral dial indicates eclipses of the sun and moon. The handle was used to advance the pointer to determine when the next eclipse would occur in the Saros cycle. As these operations were connected by the interlocking gears, the actual date of the eclipse showed on the other dial. How did the Greeks manage to devise a mechanism to reflect such complex and irregular data as the lunar cycles? The question also intrigues today's specialists in fine watchmaking. Mathias Butte, Director of Research and Development at E.W.O, decided to reproduce these ancient forgotten calculations and integrate them into a modern watch.
Je voulais pas être comme un pilleur de tombes qui vient voler une idée.
I didn't want to be like a tomb robber who comes to steal an idea which has existed for a long time, but rather like someone who approaches our forefathers with deep respect, whose goal is to recreate the antique object in a contemporary form. The original is about 20 centimeters high, and we have been able to create a 30mm movement which can easily be worn on a wrist. This Antikythera mechanism includes ingenious features which are not found in modern watchmaking.
Several writers in antiquity, including Cicero, mention the existence of similar machines, but the Antikythera mechanism is the only one which has been recovered. Who invented this machine? For whom and for what purpose? We still have no answers to these questions, but research continues, constantly uncovering further mechanical and mathematical subtleties, adjusting our perception of the ancient world and its technology.